This video is about statistics, sampling and distributions. It may be a bit of a surprise to find that we're very nearly at the end of the course and we haven't yet defined what a statistic is, but that's what we're going to do now. You may get asked in the exam to define a statistic, and this is the answer. It's something you can calculate using only the numbers in a random sample. If a calculation requires population parameters like mu or sigma, then it's not a statistic. So let's suppose we're looking at, let's have a fairly small class, and we're looking at the number of times in the last 6 months that individual students didn't complete an assignment. So let's suppose that these are the numbers. So we've got a small class, and we've got one person didn't hand their assignment in 3 times, one person didn't hand them in twice, these always handed them in, and so on. If we work out the mean, or we work out the maximum number, 3 in this case, or we work out the variance, or even if we just work out the total, then these are statistics because we're only using the numbers in this sample. However, if we were to use these numbers to estimate the mean number of all students, not just in this class, and then we did a calculation using that estimated mean, then that would not be a statistic, because that would be using a number that's not in this random sample. So it's only the numbers in this random sample here that we can use if we're going to call it a statistic. Now we're going to consider a sampling distribution. And what is a sampling distribution? Well, it's the probability distribution of a statistic. So if we've got certain numbers, 1, 2 and 3, and the probability that x is 1 is 1/4, and the probability that x is a half is 1/2, and 3 is 1/4, this is a sampling distribution. It shows the probability of each of these numbers. So this will become clearer when we work through this question. So we've got some Roman coins with denarii and sestari, and we've got twice as many sestari as denarii. Each sestari is worth 1 unit, each denarius is worth 4 units. So firstly, let's work out the mean and the variance. So if we've got a 1 unit and a 4 unit coin, the probability that we have a 1 unit coin is 2/3. The dog didn't seem to like that, but that is true. And the probability we have a 4 unit coin is 1/3, because we've got twice as many sestari as we have denarii. So let's do x times px, so that's 2/3 and 4/3. Let's do x squared times px, so that's 2/3 and 16/3. Let's add these up. 2/3 plus 4/3 is 6/3, that's 2. 16/3 plus 2/3 is 18/3, that's 6. So the mean is the expected value of x. The dog doesn't seem very happy, but this is correct. That's simply sigma x px, which is 2. The variance is the expected value of x squared minus the expected value of x all squared, which is sigma x squared px minus mu squared. So sigma x squared px, that's this, that's 6, and 2 squared is 4, so the variance is 2. So with the same scenario as we had before, we're going to take 3 coins at random, we're going to list all possible samples, and then find the sampling distribution of the mean. So we could have a 1, a 1 and a 1. 1, 1, 4, 1, 4, 1, 4, 1, 1, 1, 4, 4, 4, 1, 4, 4, 4, 1, and 4, 4, 4. I've done this in a slightly strange order, but this is going to make sense in a minute. So we've now listed all possible samples, so that's this bit done. Then we need to find the sampling distribution of the mean. So let's find the mean of 1, 1 and 1. And that's 1. 1, 4 and 4, that's 2. 1, 4 and 1, that's 2. 4, 1 and 1, that's 2. Add them up and divide by 3, that's 2. 4, 4 and 1, that's 9 divided by 3 is 3, and that one's 4. Now, remember that there are twice as many sestari as there are denarii, so the probability of getting a sestari is 2 out of 3. So the probability of getting a 1, 1, 1 is 2/3 cubed. The probability of getting a 1 and a 1, that's 2/3 squared. And then we need another 4, so that's times 1/3. And the same for this one. We've got 2 sestari, and we've got 1 denarii. So the probability of getting a 1, 4 and a 1 is also 2/3 squared times a third. And the same for 4, 1, 1. So in fact, all of these three have the same probability. So the probability that we get a mean of 2 is that. Similar sort of thing for 1, 4, 4. To get a 1 is 2/3. To get a 4 is 1/3. So it's squared. And it's the same for here. We've got 2 denarii and 1 sestari. So again, because we've got 1, 2, 3 of those, that's 3 of those. So they're all the same. Now this one is obviously 1/3 cubed. So if we've got x being the mean, which is either 1, 2, 3 or 4, then the probability of x, I should write x, is mean. The probability of getting a 1 is 2/3 cubed, that's 8/27. The probability that the mean is 2 is 3 times 2/3 squared times a third, works out to be 12/27. The probability that the mean is 3 times 2/3 times a third squared, works out to be 6/27. And then a third cubed is 1/27. Just as a double check, 8 and 12 is 20, 20 and 6 is 26, 26 and 1 is 27, so we've got 27/27. So this is now our sampling distribution of the mean. Now let's do another example, and this time let's find the sampling distribution of the median. So the median of 1, 1 and 1 is 1, the median of 1, 1 and 4 is 1, 1, 4, 1 is 1, 4, 1, 1 is 1. So all of those have median 1. The median of these is 4. Remember, the median, you have to write the numbers in order and find the middle number. Now in the last example we worked out the probabilities, which are these ones here. So the probability that the median is 1 is this number plus this number. So we can set it out in the same way. This time we're going to call it the median y. The probability that y is 1 is that plus that. That works out to be 20/27. So obviously there's only one other possibility, that's 4, so that must be 7/27. We could check that by working this out, adding them together. But this is the sampling distribution of the median in this example. Here's the last example. 80% of the travellers between London and Paris make their journey by Eurostar. A random sample of 10 people is chosen, and the random variables x1 up to x10 are defined as 1 if they travel by Eurostar and 0 if they don't. Write down the distribution of the sum of xi from I equals 1 to 10. This looks very hard, but in fact it's quite straightforward, because all this is saying is we've got to add up these numbers, and if you add up these numbers, that's going to be 1 for every time someone did travel by Eurostar and 0 if they didn't. So if you add up those numbers, you're going to find the total number of people who travel by Eurostar, even with this spelling mistake. So what we need to do is to find the distribution of the number of people that would have travelled by Eurostar, thinking of success as being travelled by Eurostar, and we've got 10 events. What this is saying is that the distribution is simply a binomial distribution with 10 events, and the probability of success is 0.8. And then in part B, we have to find the probability that xi equals 9 and add the probability that xi equals 10, because that's what this is saying. Add up the probability that it's greater than or equal to 9, so it's 9 or 10. So what's the probability that xi equals 9? Well, that's 10c9, 0.8 to the 9 times 0.2. It's binomial distribution. This one is 10c10, 0.8 to the power 10 times 0.2 to the power 0. And that works out to be 0.376 to 3 significant figures. So this question looks really difficult, but in fact it's very, very straightforward. It's just a simple binomial.